So now we're going to look at different types of variation, which include inverse, joint, and other combinations. So we've looked at direct variation, which is in the form y equals kx. So as x increased, so did y, and it increased by a constant of variation k. Now inverse variation is kind of opposite to that. So as x is going to increase, y will decrease, or as x increases, y decreases. Now we still have our constant of variation k. We will just have a different relationship between x and y. Now this is the standard way to represent inverse variation, but it can be rewritten in these other two forms. So suppose x and y vary inversely, and we have x equals 4 and y equals 12. So that means we have y equal to k over x. Now y is 12 and x is 4. So now we just need to solve for k. Well, we're going to pretend that this guy is over 1 and we're going to cross multiply. So you can either cross multiply or just multiply each side by 4. So we're going to get 12 times 4, which is 48. So k is going to be 48. So the function that models this relationship is y equals 48 over x. And this function will model all of the different coordinates that relate to this inverse relationship, including 4, 12. So we've looked at direct variation, which is y equals kx. We've just glanced at inverse variation, which is y equals k over x. Now we're going to look at combined variation, which is taking both of these two ideas and putting them together, as well as joining more than just two different unknown values. So here are a couple instances of combined variation. So let's say z varies jointly with x and y. So now instead of one variable varying directly with another, it's the product of two variables varying directly with another. Okay, we still have our constant of variation k. If z varies jointly with x and y and inversely with w, that means x and y is going to be on the top because it's like our direct variation, and w, since it's inversely, will be on the bottom. Now notice how k is always on top. So z varies directly with x and inversely with the product of y and w. So this time the product is on the bottom and x is on top. Now all of these have k, which are constant, and all of them have k on the top of a fraction whenever there is a fraction. So remember, jointly means together. So if x and y jointly vary, that means they are multiplied and they are a product and they are together. Inverse means you put that value on the bottom, and k is always on the top of that fraction. So let's say we have x equal to 2, y equal to 3, and z equal to 60. And we are told that we want to write a function that models when z varies jointly with x and y, which means z varies jointly with x and y, and we have to have our constant of variation. Well, we have all of our unknown values other than k, so we have 60 equals 2 times 3, which is 6. So solving for our constant of variation here, k is going to be 10, which means the function here is going to be z equals 10 times xy. Now we want to figure out what is z going to be when x is 4 and y is 9. So what is z, since I know k is 10, when x is 4 and y is 9? So multiplying all of these together, 4 times 9 is 36. 36 times 10, we're going to get 360. So go ahead and give these a try. Each one you need to write the function that models the variation, and then you're going to find the missing variable given the other values in that function.